Dr. Babasaheb Ambedkar Open University.
Hello dear students and learner, I Kamesh Rawal welcomes you in the video lecture series of Dr. Babasaheb Ambedkar Open University. Here we are discussing a subject called Computer Fundamental and Information Technology. I think in the last session we have focused on what actually the computer is, right? So basically we have tried to give a definition for the computer. Later on we have seen the different generation, right? And we have discussed that the originally when we have started to build a computer, at that time our overall intention was to build a machine which can perform a fast calculation. But today we know that there are several things are there which we can do with the help of computer, and in that we are using a lot many things. For example, let's suppose if we are sending a mail or we are doing a chat with the friends, these are the activities in which there is no computation is involved, right? So we have defined the today's computer as a data processor, right, which takes an input from the user. Input is nothing, it is a kind of unstructured facts and unstructured raw material, and that is actually processed by the system and it produces the output. Along with that, we have also seen the different generation, and in every generation we know that some technology, some technological changes that we have made to build our latest computer. Okay. After this generation, we know that in the first generation we have we have used vacuum tubes as a technology, and there are so many drawbacks are there of using that vacuum tube. So in the second generation of the computer we have used a transistor, which is a small device made by a germanium. Afterwards, in the third generation, the transistor we have replaced with the IC technology, where all the electronic component we have built by using a silicon, right? So the size of the transistor get reduced by 10 times, and we are successfully we have placed all those small transistor or electronic component on a small silicon wafer. This is called the IC technology, right? So we know that how the different generation will have a different technology. Now in this particular session we will just discuss about a classification of the computer, right? So according to the size, the functionality of the computer is actually roughly divided into several categories. Now we will see what are the categories are there, right? So the first category, that is called a microcomputer, right? Second category is nothing, it is a mini computer. Third category is a mainframe computer, and the fourth category is a supercomputer, right? So there are some hardware, some softwares are there which is associated with a particular classification of the computer. Okay, now let us start to discuss what actually the microcomputer is. So see, the microcomputer were actually originated in somewhere around 1970, right? So before this 1970, the generations, different generation as we have discussed, that is actually going on. But in 1970 the microcomputers were originated. The first microcomputer were built of 8-bit microprocessor chip. Now what is this 8-bit? We are just coming to this point. Okay. What different type of microcomputers are built during this time period? So Intel 8080, MOS 6502 and MC 6809. These are the examples of the microcomputer, right? In fact, let's suppose if you are using any personal computer, or if you are using any computer at the office, or if you are using a laptop, these are all we can say is the example of microcomputer, right? So right now whatever we say, a PC or our computer at our home, right, or computers at offices, right, they are all comes under this category which is called a microcomputer. Now in the microcomputer there is one small chip is there which is known as a CPU, or we can say central processing unit, right. So the chip itself is known as a microcomputer. Okay. The microcomputer consists of a microprocessor, right. So that is nothing, it is a CPU. Then later on we will discuss what are the components are there of the CPU. It is a and in the microcomputer, apart from the microprocessor, there are semiconductor memories are there. For example, RAM, it is known as a random access memory, and a ROM, that is called a read only memory, right. These two memories are actually required to process the data. Fine. Now as I said, this particular thing, this is called 8-bit. Now what 8-bit means? So see here, when we are soldering the different electronic component on the motherboard, for example, let's suppose if you think this is our CPU, right. So let we have this is a CPU. So this is one electronic component which we have placed on the motherboard, and you just think here what we have is we have a random access memory, right. So it is a RAM. So here basically there are two main components are there, and both the components we are just plugged into the motherboard, right. Okay. Now you just think before starting any kind of processing work, the data is actually available in the random access memory, right. Now obviously who is actually doing the processing work? That is our CPU, or we can say it's a microprocessor, or it is a central processing unit. So here we have the CPU, right, and every processing work will be carried out by the CPU. Okay. Now the thing is, how can we pass the data whatever we have stored inside the memory to the CPU for processing purpose? So obviously you can think here some wires are there, right. Let's suppose this is a wire, and through the wire we are just connecting this we can say random access memory and CPU. Now you just think how suppose in the random access memory, let's suppose if you have a 16 bits of data. Okay. How many? 16 bits of data. In fact, we will just come to this point, right. What is 16 bit? What is bit actually, right. So we are just coming to this point when we will see how the memory can be measured, right. Okay. So let's suppose if you have a 16 bits which is stored in the random access memory, and you want to process that 16 bit by a CPU. So obviously if there is only one wire is connected with the CPU and random access memory, here you can transmit how many? Only 1 bit, right. Then this to transmit this 16 bit from a random access memory to CPU, obviously you need to wait for 16 seconds, right, because in a one clock tick, in a 1 second, obviously you can transmit only 1 bit. Why? Because we have only one wire connected between this random access memory and CPU. But let us assume, let's suppose if we have 2 wires connected, right. So in that case you can say in a 1 second we can transmit 2 bit at a time, because there are 2 paths are there, right. There are 2 wires are there which is actually connecting your CPU and random access memory. Similarly, if you think if there are 8 wires are there, right, which is actually connecting the random access memory and CPU. So obviously in a 1 second, in a 1 clock tick of the system, you can transmit 8 bit of data together in a 1 clock tick, right. So to transmit 16 bit you need only a 2 clock tick, fine. And that is what, if more number of bits are there between the width of the bus, this is called a bus which is actually carrying the data from the random access memory to CPU, this is called the bus, right. Now suppose if the width of the bus is a larger, for example instead of 18 bits, suppose 16 bits are there or 32 bits are there, obviously more data, more bits you can transmit from the random access memory to CPU as well as from CPU to random access memory, right. And that actually increases the speed of the computer. So originally when the first microcomputer has been invented during this 1970, at that time the first machines are of 8 bits. What you have to understand by 8 bit, there are 8 wires are there which is actually connecting to CPU and your random access memory. Fine. Okay. In early 1980s, a 16 bits CPU chip is invented, right? So let's suppose if we'll talk about Intel 8086, okay, and Intel 8088, where these are the architecture which is invented during 1980s. These are always again it's this is microcomputer chips, right? But here the bus width, right? The CPU's bus is increased from 8 bit to 16 bit, right? So here the 16 bit machines are made in 1980. Again, if we will talk about that previous 8 bit machine or the 16 bit machine, both are actually a microcomputer. But as I said, if more number of more number of bits are there, it actually increases the speed of the system, right? So in 1980, two model are invented by the Intel, and it was Intel 8086 and Intel 8088. Fine. 8088, if we will talk about Intel 8088, so that is having 8/16 bit of chip. Now what is it actually? See, usually when the computer is actually processing the data, at that time the data will be available in the hard drive, right? I think we people are also known as this hard drive as a hard disk, right? So here usually we have a secondary memory, and that secondary memory is nothing, it is called a hard disk. And here what we have is, we have the another memory which is called a random access memory. So this is a random access memory, right? And here who is actually processing the data? Obviously the data will be processed by our CPU or microcomputer chip or central processing unit or processor, right? So this is our processor or CPU, whatever you say, everything is same, right? If you talk about a microprocessor chip or central processing unit or processor, right, or CPU, that is same thing. So this is our CPU chip, right, which is actually responsible to process the data. Now usually what happen, the data whatever we are producing or saving, that are available on the hard disk. But due to the speed mismatch, the hard disk is very slow compared to the speed of the CPU, right? So CPU don't want to interact directly with a hard disk, right? CPU never interact with the hard disk directly. So here what happened to reduce the problem of the speed mismatch between the hard disk and CPU, what we have is, we have the additional memory we have placed, and that is called a random access memory. So first of all, what we need to do is, if certain amount of data which is available on the hard disk, and let's suppose if we want to process it, we just need to load this data into the random access memory first, and from this random access memory the data will be picked up by the central processing unit. It will process the data. Okay. Now how to transmit a data from hard disk to a random access memory? So again, here the bus is there, right? And what is bus? Bus is somewhat, we can say, there are so many parallel wires are there, they are carrying the data from one end to another end. So here in this 8086, 8 bits of bus they have used to transmit the data from your secondary memory, that is hard disk, to a random access memory, right? And once the data is available in the random access memory, right, to fetch the data, to load the data into the microprocessor chip, here 16 bit of bus is placed, right? Okay. So in 8086, 8 bit, it is the width of the bus which is carrying the data from hard disk to random access memory, and 16 bit 16 bit bus is used to transmit the data from random access memory to a CPU. Similarly, right, obviously we know that here only 8 bits are there, right, and here 16 bits are there. So in the next CPU 8086, they have increased the width of the bus, right? Which bus? The bus which is carrying the data from hard disk to random access memory. So here both bus, right? The bus which takes the data from the hard disk and it is putting it into the random access memory, and the second bus which actually fetch the data from the random access memory to CPU. Both the bus width has been same here, and that is nothing but it's a 16 bit. Later on Intel has designed a new processor, and that processor is a 1632. How you will understand 1632? So obviously the width of the bus which is carrying the data from hard disk to random access memory, that is 16 bit, and the bus which is carrying the data from random access memory to CPU, it is a 32 bit, right? Nowadays if you are talking about your mobile phone or the computer, latest computer, whatever we are buying from the market, they are 64 bit, right? So let's suppose if we are buying any laptop or if we are buying any desktop machine, so they are available with a speed of 64 bit, right? It is having a 64 bit microprocessor chip, right? Okay. So I'll just show you how the data will be transmitted and how the bus looks like, right? So in the next screen here, one electronic board is there. You can see these are the electronic components, right? This black portion, right? The black portion, whatever we can find here, it is called integrated circuits, right? And here there are many legs are there, right, which is actually shouldered with the board, right, or main board. Fine. Now from this legs the data will be transmitted, right, and here you can see a small lines which is painted on the board, which is actually carrying the data from one electronic component to another electronic component. For example, here you can see there are so many parallel lines are there, right? Now suppose if there are 8 thin wires are there here, that means at a time we can transmit 8 bits of data, right, and we can say the system is of 8 bit. So in 1980 a 16 bit CPU chip has been invented by the Intel Corporation. Now I think you people are already aware with what actually the 16 bits mean, right? So here let's suppose if you will talk about random access memory, right, and if we have a CPU. So this is a random access memory and this is your CPU chip, for example, right? It's your central processing unit. So between these two, there are 16 wires are there. So the width of the bus is what? 16 bit, right? So at a time what we can do is we can transfer 16 bit of data from a random access memory to CPU, right, for processing purpose, and once the CPU is doing the processing work, then entire 16 bit of data we can send it back to the random access memory. So here to transfer a 16 bit of data from a random access memory to CPU or from CPU to random access memory, we need only a one clock tick, right? So obviously compared to the previous microcomputers, the speed of this microcomputer get enhanced, get increased, right? Okay, because here more amount of data we can transmit from a random access memory to CPU at the same time. Okay, afterwards what happened in in 8080 there is 8 16-bit chip was invented, right? Now what it mean actually? See, usually what happen whenever we have the data, that data generally we are putting on the secondary memory. Why? Because the secondary memory can store the data permanently. Okay, now see what happened. The secondary memory, you can understand your hard disk, right? So let's suppose if we have the hard disk, then this hard disk is a secondary memory, right, which can store a huge amount of data. So here we have the hard disk, which is our secondary memory. Now see what happened, the hard disk having many benefits. It is available in a larger size, it can store the data permanently, but there are certain drawbacks are there of the hard disk. The main drawback of the hard disk is what? it is very slow compared to the speed of a CPU. CPU is, it's a tremendous fast, and compared to the speed of the CPU, hard disk is a very slow device, and due to that reason CPU don't want to interact with the hard disk directly, right? So usually to overcome this problem, to sort it out this particular problem of a speed mismatch between the hard disk, secondary memory and CPU, we have inserted another memory which is known as a random access memory, right? So here we can say the random access memory, it is a faster memory compared to our hard disk, right? So hard disk is obviously one memory, but because of hard disk is a slow memory, here to overcome the speed mismatch problem between a hard disk and CPU, we have inserted a additional memory which is called a random access memory. Now see, first of all, the CPU, because of the speed mismatch problem, CPU never interacts with the hard disk directly, right? So here what happened, first of all we just need to transmit all the data from the hard disk to a random access memory, and once the data is available in the random access memory, then we can send that data to the CPU for processing purpose. Okay, so here there are two buses we are using, right? One bus will carry the data from hard disk or secondary memory to a random access memory, and a second bus which will carry the data from a random access memory to our CPU, right? Here in the case of 8088, the bus which is used to transmit the data from hard disk to RAM is of 8 bit, okay, and the bus which we are using to transmit the data from a random access memory to CPU, it is a 16 bit, right? So in 8080, 8 bit and 16 bit, two buses were used, okay. Then if we talk about 8086, right, so in that both the buses, right, so first bus which actually carries the data from hard disk to a random access memory, and second bus which carries the data from random access memory to CPU, the width of both the bus are set to equal, which is a 16 bits, right? So 16 bit bus is used to transmit the data from hard disk to RAM, and another 16 bit bus is used to transmit the data from a random access memory to CPU. Recently, if you are buying any computer, right, whether it is a desktop computer or it is a laptop computer, nowadays whatever computers are available in the market, they are using 16 bits of microprocessor, 64 bit of microprocessor, right? So nowadays 64 bit of machines are available in the market, right? So if you are buying any computer, whether it is a desktop computer or all-in-one computer, or if it is a laptop computer, you will definitely get a 64 bit microprocessor chip in that particular machine. Okay, so this is something about a microcomputer, right? Now here I have shown, you people are little bit confused with what actually the bus is, how can it transmit the data from one device to another device. So here I have shown a close photograph of the motherboard, right? So you can see here this type of small chips are available on the board. I am just making a circle on the chip, and this type of chip is nothing, it is called IC, it is called integrated circuit. Fine. Now from any integrated circuit or from any electronic component to any other component, you can see here there are some lines are painted on the bus, right? Lines are painted on the board, and this is what it is called the bus, right? It can carry, you can consider these lines are one kind of wire which carries a electronic signal from one component to any other component, right? Here you can see some lines are drawn, and these lines are actually a wire which carries the data from one electronic component to another electronic component on the board, right? So this type of things are there, which is actually a bus, right? Now suppose if there are 8 wires are there, if there are 8 lines are there between two components, we can say it's a 8 bit, right? but suppose if there are two components are there and between them there are 16 wires, 16 lines are there. So what we can say is this is a 16-bit machine. Nowadays 64-bit machines we are enjoying, right? Okay, now this is, here I have shown the photograph of the CPU, right? The CPU looks like this. Now what is actually a CPU? So see, most of the time the students are actually getting confused, right? For the students point of view, when we are working with the machine, at that time what we have is, we have a monitor, right? Then we have a keyboard, along with the keyboard we have the mouse, and then there is one metal box is there, right? This metal box obviously we are calling CPU, but make sure this is not the CPU, right? This metal box which we are using with our system, right? And all we can say input and output devices like monitor or mouse, we are plugging with this particular metal box. It is known as a cabinet, right? So that is actually a cabinet. This cabinet has a motherboard, this cabinet has a CPU, this cabinet has a secondary memory like hard disk, CD-ROM, power supply unit which is called the SMPS, and lot of components, right? So in this particular box there are so many components are there. Obviously CPU is one of that component, right? But there are so many components are there. For example, motherboard, CPU, random access memory, hard disk, SMPS, CD-ROM drive. So many components are fitted into this particular box, and this box is not a CPU, it is known as a cabinet. Then what is CPU? CPU is a very small chip, right? Here I have shown the photograph of the small chip, right? And this is what is a front and back look of the CPU. This is called a chip, which is also known as a microprocessor chip. Sometimes you can say it's a CPU, or you can say it's a central processing unit, right? So whenever we are talking about a processor, the processor is a small chip, right, which is inserted on the motherboard, and then we are fitting that particular motherboard in the cabinet. Okay, so now onwards you don't have to say the cabinet as a CPU, right? Okay, fine. So this is something about a microcomputer. Now there is one more computer is there which is known as a mini computer, right? Now what is actually a mini computer? So mini computer is somewhat, we can say it's a more powerful than the microcomputer, right? So a mini computer, it is a small machine and it is a general purpose machine, right? You can use it for any purpose. You can work with the Word or Excel or PowerPoint. You can do some programming kind of thing with this mini computer. So it is a general purpose machine, right? So mini computer, it is a small general purpose machine. Mini computer is more powerful, as I already told you that, right? Mini computer is more powerful in terms of processing speed than a microcomputer, and due to that reason, because we have in a mini computer we have more powerful processor. Here what you can do is you can take a one machine, right, and there are many users are there. Let's suppose this is the machine and this is a user, right? So this is a one user, this is another user. So many user can work with this machine simultaneously, right? Suppose if you have 10 to 15 users, obviously what you need is you need a one mini computer, and which is able to process the data of 10 to 15 different user at the same time. Okay, so this is what the power, right? So here what we can say is mini computer is nothing, it is a more powerful than the microcomputer, right? Obviously microcomputer can be used to process the data of only one user, right? Here mini computer can process the data of many users simultaneously. How many? 10 to 15 users. Fine. Mini computer is a small but expensive machine, right, with I/O supports. So obviously because this is a machine, here you can attach so many input and output devices, right? It is a little bit costly than microcomputer, right? Because obviously it is a powerful machine, so obviously some cost has to be there. Okay. Mini computers are mainly designed to support multitasking. Now what is multitasking? See, nowadays what we are doing is we are using a Windows kind of operating system or Android operating system in our phone. This operating system allows us to run more than one program at the same time, right? So more than one program if we are running at the same time, it is known as a multitasking. Fine. Another machine is there which is called a mainframe computer. Now what is actually a mainframe computer? So mainframe computers are more powerful than the mini computer, right? Mainframe computers are generally available which will have a width of the bus, it is more than 32 bit. So 32 bit, 64 bit, 128 bit of mainframes are available, right? Mainframe is a more powerful machines than a mini computer. So you just see this, more than 100 users can connect with this particular machine and 100 user can do their work, right? Mainframe computers are that much powerful machine which can process the data of 100 users at the same time, right? Obviously variety of programming languages supported by the mainframe, right? Mainframes are very costly machine and they are very huge in the size, right? Here there are several examples are there of the mainframe computer, MEDA, Superi, ICL, DEC, these are the examples of mainframe computers. Okay, the last and final machine is called a supercomputer. So obviously supercomputers are most powerful, right, among all, right? It is more powerful than microcomputer, mini computer as well as a mainframe. So we can say more powerful mainframes are a supercomputer, right? So supercomputers are most powerful machines, right? They are very we can say fast in speed, so very high speed processing power is there. Generally it is used for a complex scientific computation, right? Supercomputers are very costly and the cost of the supercomputers are ranging from 4 million to 17 millions of US dollar, right? So these are the very costly machines. It's a very huge machine. Okay, Cray XMP, ETA, IBM 3090, NEC and Hitachi S series are the examples of supercomputer, right? Supercomputer can process 25,000 million arithmetic operations in a 1 second, right? India has developed its own supercomputer and the name of that supercomputer which is developed in the India is a Param, right? So Param is the supercomputer which is developed by our country India. Fine. So that's it. In today's session we have seen what is microcomputer, what is mini computer, what are mainframes and what is supercomputer. I think sufficient discussion we have made in our today's session. We'll discuss few more topics in the next session. Till then, take care and bye bye. Thank you.